these two chain rule problems are very similar to each other. I picked them because they have 4 layers that you have to unwrap to get to the final derivative. So the first thing we're going to do is, with the sine to the 4th of 5x, just rewrite that as sine of 5x parenthesis to the 4th. The books will always write it the first way, but it's easier to take the derivative if you rewrite it this way. So this is just y still. Alright, so now dy dx. So with chain rule you have to work from the outside in, and so the outermost layer in this problem is the fact that we have a quantity to the 8th power. So the very first thing is to take that derivative, which is 8, and then recopy everything that was inside just as is. You're not going to change that at all or take its derivative or anything yet. And then that's to the 7th. Now we work our way from the outside in. So now the next outermost layer is this part. And the derivative of 2 is just 0. So we don't need to write anything for that. So then we're going to be taking the derivative of sine of 5x to the 4th power. And it itself is a chain rule. So the first step for that is 4 times the sine of 5x to the 3rd power. Then the next inside portion is the sine of 5x. So its derivative we multiply cosine of 5x. And see, each time we're still rewriting the same inside. Like right there I just wrote 5x still. But then 5x is the innermost function, and so at the very end we multiply by its derivative, which is just 5. And this is the answer, but what you want to do is go through and find all of the coefficients, which is the 8, the 4, and the 5, and just multiply those together, which would be 160, and then rewrite the answer like this. Dy dx equals 160, and then just basically copy everything else back down. Sine of 5x to the 4th, to the 7th, sine of 5x to the 3rd, and then cosine of 5x. And that's the final answer for this one. So we just worked our way from the outermost function to the innermost function and multiplied each derivative as we went. So let's try this other example. It's very similar. So first we're going to rewrite the secant the same way as we did in the first problem. So we have secant of x to the 4th to the 3rd, and then there's everything else. So this is still just y. Okay, so now we're taking the derivative. So again, the outermost portion is the fact that we have this quantity to the 9th power. So its derivative is 9. Recopy all of the inside stuff. We don't change the insides. And then that'll be to the 8th. Times, now, the next outermost portion is the stuff that was inside of the quantity. The derivative of 4 is 0, so we don't have to write that down. So we're going to do the derivative of this part, which is its own chain rule again. So we're going to have 3 times secant x to the 4th squared. Now, the next inner portion is the secant. Now remember, the derivative of secant is secant tangent. I'm going to write this on the next line since I ran out of room. But it's secant tangent, so you have to write secant of x to the fourth tangent x to the fourth. You have to keep writing the x to the fourth with both of those because it's the inside function. And just like everything else, we cannot change the inside function. But x to the fourth is the last inside function, the innermost, so then we multiply by its derivative, which is 4x to the third. And at that point, we've done all of the derivatives of all of the functions, working our way from outer to inner. And so then, like in our first problem, we're just going to find the coefficients, 9, 3, and this 4x cubed, and just multiply those together and put them in front. That just makes it more simplified. So that is 108 x to the third, and then just recopy everything else. Secant x to the fourth cubed to the eighth times secant x to the fourth squared. And we still have that secant x to the fourth tangent x to the fourth. And that's our final answer. So anytime you're doing chain rule, especially with these multiple layer problems, just work your way from the outside in and never change the inside function when you're rewriting it. And that's it.